talk about a project you did for one of Chariot's clients. Why don't you start by describing the project?
Sure. So background on the client. The client is a online gaming company that is a spin-off of a traditional bricks and mortar gaming company. So they introduced a sports gambling and casino betting using an app. And one of the interesting, this was kind of just a small project within the larger scope, but it's kind of points out a couple of interesting things about data engineering. They wanted to be able to integrate uh, this application, sportsbook and casino gambling, with their existing loyalty program for the bricks and mortar casinos. So one of the things that they had come up with as an idea is using what's called clickstream data, which is basically tracking what people do inside the app and the communications with various third-party providers, and capturing that information and putting it into a form that could then be sent to the loyalty program system. And Chariot, as part of our work with this client, which was ongoing, uh, basically put together the large part of the pipeline to get the data from the clickstream data and put it into a form that could be uploaded and sent to the loyalty program. So been a fairly short order being able to integrate this existing loyalty program with the new online gaming system application. Uh, and to me, it's an interesting project because it takes data. People think of clickstream data as being, okay, what are people looking at for products? What's the purchase funnel? You look at a product, you look at another product, maybe you put one of them in your cart and you check out. And a lot of that gets used for business intelligence purposes. So you have how many of each type of product do we sell this past week? What's the click-through rate on these ads? But here we're using this very same data to really drive an operational system. And by operational, I mean one that's used to drive the business. It's not simply analyzing what happened to the business, it's making changes and being a part of the business operations.
So how did the Chariot team approach the problem?
Basically, we approached with the client, and we are embedded in the data engineering team at the client, uh, talking over what was available. The client had this idea, what was available, and really the architecture of the way that it should best be implemented. So our general philosophy, I guess you'd say, is that with streaming data, it works very well to be tied in the AWS world. You put your data into a Kinesis stream, which lets you process it uh, and have multiple consumers processing it. And then you use generally Lambdas for things that are not overly high scale, I guess would be the best thing. So, Lambdas work extremely well where you might have a few thousand messages per second coming in. And we weren't at that level with this product versus something where you might start thinking of, okay, rather than trying to process in real time, let's try and batch things up and then process the batches. It's a trade-off of latency, the speed with which you handle the incoming messages versus being able to use techniques that let you more efficiently process large volumes of data. So we approached it as an idea of, okay, we have this clickstream data coming in. We'll have a series of AWS Lambdas that start processing the pipeline. The clickstream data has a lot of messages that we just don't care about. So the first step in the pipeline is saying, okay, ignore all the messages that we don't care about and save the ones that we do care about into what turned out to be a relational database, a traditional database. And what's nice about that, and with the streaming data of something like Kinesis or outside of AWS, the Kafka service, is that you can have multiple consumers. So we have this one stream of incoming data, and we can put the consumer that picks up people's activity for the loyalty program to look at some of the messages. Uh, I know that we had another project going on at the time that basically looked and tried to get a sense of, for large games, which way the bets were trending. But you can have all these multiple independent consumers. So we have the streaming data, we have one Lambda function that takes the streaming data and pulls out just the pieces that we care about. Now, with this particular loyalty program, it was a legacy system. It had a few quirks to it. So the subsequent processing steps, one of them tried to aggregate activity by users into basically 15-minute chunks so that we would not overload the loyalty program servers. So again, completely independent processing. We have these messages, we now aggregate them over time, and we put out messages on a queue for the next stage in the process. And the next stage in the process was designed to actually upload the credits. So again, the loyalty program service sometimes had some issues. Sometimes its updates for users weren't immediate. So sometimes we'd get in activity for a user that the loyalty program didn't know about and wouldn't know about for hours. So we ended up having this last of the system basically cycle data through. And it would keep cycling data through if the loyalty program said, I don't know who this user is, or if it was down, would just put it back on the queue and pick it up again. So it's a nice little division of labor there. One part that just pulled messages off the stream, think of it as a faucet sitting on this stream of data. Another part that did kind of all the intelligent work of aggregating the credits and putting them in a form ready for the loyalty program. And then the third point, which would actually interact with the loyalty program, had everything pre-built for it. All of these messages coming in contained everything we needed. So it was very simple, and it could try to upload the message. If it was successful, great. If it wasn't, put the message back on the queue for later processing.
Was there ever any question about using AWS?
For this client, no. This client was heavily invested in AWS. So that's pretty much going in. There have been other projects that we've worked on where we've adopted a cloud agnostic approach, where we've developed using tools such as Kubernetes that can at least theoretically be moved from one cloud vendor to another. But in this case, like I said, the client was heavily invested in AWS. AWS provided the services that solved this problem very well.
And I guess Chariot has some expertise in AWS.
Yeah, we have been working with AWS for quite a few years. My background with Chariot, I was a Chariot consultant up until 2014, left for a few years, came back, and back in the early 2000s, we had several AWS projects. In the past few years, we have focused on a cloud practice and specifically a data engineering practice within it. And since my expertise, I'm the person who's been kind of spearheading these practices, my expertise is in AWS. We tend to look at AWS, but we still, I know we had one project a year or so ago with a major consumer products company that was all based on Google Cloud Platform. Same idea of pulling data from multiple sources, processing it, and then putting it into a form that can be used, in this case, by their business intelligence team.
I'm curious about maintainability with the cloud. Like, how often do you have to go in and do maintenance and updates in this particular case?
So again, using managed services, you don't worry about the infrastructure at all. The maintenance and updates are as your code evolves or as you're supporting new features. And that actually is something that this project had an initial phase, which was supporting the sportsbook and casino applications. But then it also evolved out that inside the brick and mortar casinos, you can place sportsbook bets. And okay, how do you integrate that in? And it was basically taking the same idea, taking a different stream of data, pulling the pieces out of it that we cared about, and then feeding them down so that the final diagram of the system, you have these multiple streams of source data that all funnel down through different processing phases and then all wind up at the end doing the upload. So that was again, it's focusing on the application level rather than the infrastructure level. If you find a bug, that's maintenance at the application level or a new feature. And with that, we were in this project using Terraform, which is a tool for deployments. So we could build and deploy new editions of the software pretty quickly and pretty easily, to the extent of you deploy into test, you verify with test data, and then you deploy into production. And that whole cycle is a matter of, you could condense it down to an hour, but typically we would go with a few hours and just make sure everything shook out in development before moving into production.
Are there any items on the wish list for this client in this project?
Uh, I think we actually wrapped up the wish list for this project, this specific project. As I said, we have an ongoing team with the client, and I actually left the project a few weeks ago to start a new project. And the last thing that I did was to make sure that one of the last features of this data pipeline got deployed, had buy-off from the business because there was a change in the way that we were processing the incoming streams. And that's kind of an important thing, by the way, is again, we're thinking at the application level and not at the infrastructure level. So we start thinking about, okay, this is a better way of tracking this information. Let's focus on the actual code change is tiny. Let's focus on the actual business understanding of this change. So by dividing it up into small pieces that take a pipeline, everybody can understand the idea of a pipeline or an assembly line where you do multiple steps, multiple operations to something, and you can very clearly, they understand, oh, we're changing this step in the assembly line in this way. So I find that, from a business perspective, it makes a lot more sense to business users to talk about changing a small part of a data pipeline rather than a monolithic application.
What kind of feedback have you gotten from the client about this?
They love it. I think, if I'm trying to remember, one of the early comments when we first brought it up, and we brought it up on a tight schedule, but that feature added $1 billion of valuation to the client business.
Wow.
And I don't know if that's apocryphal or not, but it felt good to hear it.
Sounds good. Definitely. What are the main takeaways from this project?
So I think the biggest takeaway for me, and it I've been working in data engineering and decision support data for going on 30 years now. But the biggest thing for me is the thought that you have data sources that can be used for decision support, but also can be leveraged for operational data. And I think it's important when you do that to recognize the limitations of your data. Uh, Data, especially the clickstream style data, is often very dirty, has to be processed, has to be analyzed well before you use it. But part of that already comes from your decision support activities. You're looking at how you clean your data to make it useful for business information. So you can take some of the same processes and apply them and have a lot of really back and forth between, okay, we've got data for decision support. We need to apply these transformations, cleanups to it. We could use it for operational, provided we do these other things to it. So I think that's my biggest takeaway is data engineering is becoming more and more central to companies' operations. It's not simply take the data that shows how many people visited the website and how many people made purchases, but take the data while they're making purchases and perform operational activities while they're doing that. So for example, you come out, person hits a product page, and if they don't hit anything else within 60 seconds, maybe you flash up a message to them saying, if you're trying to make your decision, maybe this will make it easier. I think there's a lot of room to be doing such crossovers between what's traditionally data engineering into operational data.
That's
And
great.
that's,
Thank you so much, Keith.
oh, you're welcome. Thank you.